Okay, let's unpack this. You know that feeling when a solar eclipse happens here on Earth? That sudden, um, almost eerie dimming of the light?
Yeah, that collective gasp moment.
Exactly. Well, recently there was a solar eclipse, a real one, sun, moon, the whole deal, but not a single person on Earth could have seen it.
Which is immediately kind of weird, right? We think of eclipses as, well, our events, things we see.
Totally flips the script. This one was seen way out in space.
By NASA's SDO.
You got it. The Solar Dynamic Observatory. Now, this thing, the SDO, it's not just passing by. It launched back in, what, February 2010?
Right, that's right, 2010. And its whole job is just watching the sun all day, every day.
Like a dedicated solar paparazzi, basically. Never sleeps.
Uh-huh. And that's why it catches things we miss. Its orbit, its constant stare.
Wow.
It sees the sun from a completely different angle than we do. Geometrically different.
Which brings us to the main event here, Sunday, April 27th.
Right. What did SDO see?
It saw a partial solar eclipse. From where it was, the moon slid between it and the sun.
Okay, so a transit, from its perspective, how much of the sun was blocked?
About 23%.
Yeah.
Not insignificant, a decent chunk.
23%. Wow. But again, just to be super clear for everyone listening.
Right. Absolutely zero visibility from Earth. If you were having a barbecue that Sunday, sun looked totally normal.
Just another day down here. This was purely a space-based show, a little cosmic dance, only SDO had tickets for.
So you might be asking, why should we care? If we couldn't see it, what's the scientific value?
That is the million-dollar question, isn't it? And it's actually pretty cool.
Go on.
Well, first off, this isn't like a one-off freak event for SDO. It's seen these space-only lunar transits happen multiple times since it launched.
Ah, okay. So it's a known phenomenon.
Yeah.
From that vantage point.
Exactly. And each time it happens, it gives us data. Think about it. You're tracking the moon crossing the sun from a point not on Earth.
So you can, measure the moon's orbit more accurately?
Precisely. You're getting another data point, another angle. Any tiny little variations in the timing or how much of the sun is covered, that tells us incredibly precise things about the moon's path and the gravitational tug-of-war up there.
It's like fact-checking our Earth-based calculations from space.
That's a great way to put it. It refines the models, makes the whole picture clearer. We understand the mechanics of the solar system just that little bit better.
Okay, that makes sense. So April 27th, 23% bite out of the sun, seen only by SDO.
Got it.
But the eclipse train keeps rolling, right? There are more coming up.
Oh, yeah. The celestial mechanics don't stop. And some of them will be visible, at least partially, from Earth.
Right. NASA mentioned May 25th, a really minor one, though.
Super minor. Like 4% coverage, probably won't make headlines.
Okay, but then there's July 25th. That sounds more substantial.
Yeah, potentially much more significant. Around 62% coverage predicted for that one, depending on where you are. That's a noticeable partial eclipse.
Okay, 62%. That's getting interesting. And then for a proper, Earth-visible solar eclipse,
September
21st. But the visibility path is pretty specific. New Zealand, South Pacific, Antarctica.
Yeah.
So maybe not your backyard unless you live somewhere pretty remote.
Right, gonna travel for that one. And the next total solar eclipse, the big one.
August 12th, 2026. That's the next one everyone's really gearing up for.
Where's the path for that?
It cuts across eastern Greenland, western Iceland, and then clips northern Skane. So again, travel plans are probably needed for most people.
Imagine the planning already happening for 2026. Wild.
And all informed by data streams from things like SDO, constantly refining those predictions.
It really makes you think about perspective, doesn't it? I remember reading that the Apollo astronauts, on their way to the moon,
Yeah. What about them?
they actually saw the Earth eclipse the sun.
Whoa. Okay, flipping it completely the other way, seeing our own planet block out the star.
Exactly. Talk about a unique viewpoint. It just hammers home how much location dictates what you see in space. That's a perfect example. Ground telescopes, SDO, Apollo astronauts. Each viewpoint adds a different layer to our understanding. You need all those angles.
And slightly related but different, the article mentioned the blood moon thing.
Ah, yeah, lunar eclipses.
Right. It connected it somehow to the last solar eclipse we saw back in March. But they're different beasts, right?
Totally different. Solar eclipse. Moon blocks the sun. Lunar eclipse. Earth's shadow falls on the moon.
And the blood moon part is just the color.
Yeah, it's sunlight filtering through Earth's atmosphere that makes the moon look reddish during some lunar eclipses. Our atmosphere is basically bending the red light onto the moon. Cool effect, but different cause.
Gotcha. Different celestial alignments, different effects.
Exactly. Both amazing, but distinct phenomena.
Okay, so let's kind of wrap this part up. Key takeaway. April 27th, SDO saw a 23% partial solar eclipse.
Visible only from its unique spot in space.
Yep. And this wasn't the first time. SDO has been cataloging these space-only transits since 2010.
Providing crucial data we just can't get from down here. Constant observation is key.
And we've got more eclipses on the calendar, some minor, some bigger partials like in July, and then the Earth-visible ones in September, and the big total one in 2026.
All part of the ongoing cosmic clockwork.
The really big picture here, though, is how these tools like the SDO have just fundamentally changed things.
Absolutely. Continuous monitoring, unique vantage points. It's not just about cool pictures, it's about deep understanding. It pushes the science forward in ways we couldn't before.
Yeah, totally. And it just leaves you thinking, what else is happening out there that we can't see from Earth?
These hidden events, these different perspectives.
What other cosmic secrets are waiting for us to find just by looking from a different place or looking all the time? What discoveries are just around the corner thanks to viewpoints like SDOs?
Makes you wonder, doesn't it? What else are we missing just by being stuck on this rock?